All right, topic number 4, permutations with restrictions. So our goal today in this lesson is to determine the number of permutations when we start to have restrictions. Okay, so restrictions. Arranging letters with restrictions. How many ways can the letters in the word compare be arranged? Without restrictions or beginning with 2 consonants. So it's useful sometimes to perform a simulation to keep track of the number choices at each stage. So you can do some simulations to kind of try some things out to get a sense of it. Okay, sometimes that can be useful. But let's looking at this word compare. So we've got to see how many letters we have. C-O-M-P-A-R-E. 1, 2, 3, 4, 5, 6, 7. 7 letters. Okay. And if we're going to arrange them without restrictions, it can be any of the 7 letters. Bang, bang, bang. Basically, it's just going to be 7 factorial, because it'll be 7 times 6 times 5 times 4 times 3 times 2 times 1, which we also can write as we have 7 and we're picking 7. So whether you use your factorial on your calculator or your permutation, you should get the same answer, and you should get 5,040. Now, if we start to put in restrictions, it's going to change our results. So restrictions are automatically going to lower the results, okay? So this is our first restriction. We want it to begin with 2 consonants. So that is going to change our options. So let's map that out. The first 2 are consonants. So first we have to know which are consonants. C is a consonant, O is not, M is, P is, A is not, and R is. So we have 4 consonants. So the first letter, we have 4 choices. The second letter, we have 3 consonants left. And then we can do whatever we want with the remaining 5. So the remaining 5 can be 5 factorial. Okay, so here we have, this is the consonant, this is the consonant, and this is the rest of the letters. Okay, and we're multiplying because it's one consonant and another consonant and then the remaining 5. Okay, so when we multiply this through, or actually if we want to put it in the permutation notation, basically for the first 2 choices, the 4 and the 3, it is 4, pick 2, so our 4 consonants, and we pick 2 of them, times our 5 factorial for the rest. If you multiply those out, you're going to get 1440 for your answer. Okay? So there's 2 different ways to do it. You can set it up like this. You can do 4 times 3 times 5 factorial, or you can set it up like this, where you have your permutation times your factorial. Both will get you the same answer. Okay, but it's very useful to do a simulation, which is what the CC times the rest of them would give you. Let's look at some different restrictions, beginning with exactly 2 consonants. Beginning with exactly 2 consonants, that is, the first 2 letters are consonants, and the third letter is not. Third letter is not a consonant. Okay, so that is going to change some things, and we're going to map out a simulation. So that means that our first choice is got to be a consonant, then times a consonant. Then the third choice has to be a vowel, and then the rest. Okay, so the beginning starts the same. 4 times 3, right? And then vowels, we have, the word was compare, right? So we had 4 consonants, 7 letters, so we have 3 vowels, right? So we wouldn't have used any of them because we've only used consonants, so we use our 3 vowels. And then we have the 4 remaining, so 4 factorial. Okay? Now, we can also write this out in using our permutation things, but we have to kind of identify each step, right? So we have 4p2 for the first one, and then we have 3p1 for the second one, and then we have, 4p2 is for the first two. This is for the two consonants, right? And this is for the vowel. And then we have 1, 2, 3, 4, and that's going to be 4p4 for the rest of them. So we have 4, and we can pick whichever ones we want, or we can write that as 4 factorial. Either way, when we put that in, we get 864. Okay? But it is convenient, very convenient to do this mapping out, this simulation, so you're kind of saying, okay, what's going on? And then mapping out your what's your strategy math-wise. So let's look at the next one. In the next one, we have alternating consonants and vowels. So let's map that out. So we're going to have consonant, consonant, then vowel, then consonant, then vowel, then consonant, then vowel, then consonant, right? That's 7. So with the first one, we have 4 consonants, right? We have 3 vowels, right? Now at this point, our second consonant, we're only going to have 3, and we're going to have 2 vowels left. Consonants here, we're going to have 2 consonants left. We'll have 1 vowel left and 1 consonant left. Now when we look at what we have, we've got 4 times 3 times 2 times 1. So that's 4 factorial. And then I have 3 times 2 times 1 for my vowels. So I basically have 4 factorial times 3 factorial, which is equal to 144. You could also just multiply your numbers. 4 times 3 times 3 times 2 times 2 times 1 times 1. Okay? But mapping it out, your choices, helps you kind of discover what the answer. Okay? Let's look at the next restriction. It says M is not the first letter. So looking at this, the first letter is not M, and then all the other letters are the rest. Okay? So how many letters are not M? 6 of them. And then for the rest, we're going to have 6 factorial. And we would get as our answer 4,320. Okay? Mapping out what's happening first, second, third is really a great strategy. I have to do it, so why wouldn't you? Helps keep you organized in terms of what's going on. Example 2, arranging people with grouping. All right, so we're going to draw some pictures, which I always love. And here we have a family consisting of 5 people, 2 adults and 3 children, are going to a movie. In how many ways can they sit in 5 adjacent seats under the following conditions? So we're going to look at some conditions. So in the first example, or first condition, the parents must sit together. So the parents must sit together. So if we sketch that out, that means that we have we've got 4 entities. Okay? Because we have to have in one box A1 and A2. They have to be together. And then we have 3 children, which we can map out as C1, C2, and C3. The A's are together because they're sitting together. So that means we have 4 blocks of things. I could put A1, A2 in between C1, C2, or in between C2, C3. That's fine. So here in total we have 4 entities. Okay? So within the adults, and I'm going to just highlight them with red, the adults can sit in either order, A1, A2, or A1, A2, or A2, A1. So within the adults, I have a 2 factorial because they could be flipped. I also have the 4 entities. They can all be shuffled, right? The 4 entities of the grouping. So that would be 4 factorial. And when I multiply those together, I get 48. Okay? Now the second choice is the children must sit together. So when we map that out, I have A1 and A2, and they can split up on either side. And then I have all of the children sitting together, C1, C2, and C3. Now within that group of kids, they can shuffle. But I have 3 entities, right? I'm actually going to write that in red. Okay, so I have my 3 kids. They can be shuffled in a variety of ways, so there are 3 factorial. And then I have the 3 entities of adult 1, adult 2, and then the group of kids. So those would be 3 factorial. When I multiply these together, I get 36. Okay. Alrighty. The next situation, the next arrangement is the children must sit together and the adults must sit together. So again, I have my adults sitting. I want to use red and it's going to black. So I have A1 and A2 sitting together. And then I have my children sitting together. C1, C2, C3. Okay? And here I have 2 entities. Now, for the adults, within the adult block, it's 2 factorial. For the children, within the children block, it's 3 factorial. And then for the groups of them, it is 2 factorial. When I multiply those together, I get 24. Okay? So even though you're multiplying now 3 things, it's still a smaller number of options than the one prior. Okay, so keep that in mind. Now, let's look at this last criteria. It says, the father must not sit in the middle. So, what we have to do is we have to map that out. We have to map out exactly what's going on. Okay? So, looking at our picture, that means that if we have this mapped out, there are our seats, right? What we have to do is we have to take all the options minus the one where the father is in the middle, okay, to get our answer. So it's going to be all of our choices, so that anybody's sitting anywhere, and we subtract the father is in the middle. Okay, so this would be with the father in the middle. I have 4 choices there, 3 here, only 1 there, 2 there, and 1 there. Okay, just using my factorials. So what that actually looks like is a 4 factorial. Now all of the options are if we have 5, 4, 3, 2, 1, which is a 5 factorial. So what I'm going to do is I'm going to take all of my choices, which is 5 factorial, and I'm going to subtract the one where the father is in the middle. That's this one. So subtract 4 factorial. And when I do that, I get 96. That was a little tricky in terms of finding your solution. because it's just, how do you kind of figure out that kind of arrangement? In terms of what's going on there, right? There's other ways you could approach it, because we have these 5 seats. So if you say for that middle seat, you only have 4 options, right? Once that's gone, then you would have 4 there, 3 there, 2 there, and 1 there. I think that would work and give me this. I'm just going to test it. Yeah, because that's how I would do it too. Because this also gives you 96. Because basically it says this middle seat can't include the father, so there's only 4 options. And then you pick that person, so then there's only 4 for the 4, 3, 2, 1 for the remainder. So there's 2 different ways you kind of could approach that one. It's kind of a tricky one to kind of think about. Okay, we'll do some more arranging, hopefully. Click. I think it's important to note that there are different routes to get the answer in these things, depending on how you think about them. And I don't think you have to be a stickler for I have to do it a certain way. So if there's a way that it helps you understand what's going on, do that way. So we're going to just look at some different ways. So looking at this, at a used car lot, 9 different car models, 3 of which are red, are to be parked close to the street for easy viewing. How many ways can the 9 cars be parked if there's always a red car at each end and the 3rd red car is exactly in the middle? So let's map that out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have, let's talk about our red cars. We've got 3 on the one end, 2 on the other end, and exactly in the middle we have the 3rd red car. Okay, now for the rest of the cars, which we don't know what color there are 6 of them. So there's going to be 6 possibilities there, 4 there, 6, 5, 4, and then 3, 2, 1. Okay, if we multiply that through, we're going to get 4,320. Okay, now looking at the numbers there, I have a 6, 5, 4, 3, 2, 1, which is 6 factorial. And then I also have in my red, I have a 3, 2, 1, which is 3 factorial. And if I multiply those, I will get 4,320. So whichever way you multiply to get your answer, one might save you some calculator work. But you can really see when you draw it out how mapping out the picture of it helps. Let's look at this next situation. It says all 3 red cars must be parked side by side. So we have 1. So when we're looking at this, let's draw it out like we did with the movie theater. We have 1 block. Sorry, I'm going to spread them out in there. Which is 1, 2, 3 red cars, right? And then we have the other cars. So I have my 1, 2, 3, 4, 5, 6 other cars. Okay, so in total, I have 7 entities. And within the red car, I have 3. That can be arranged by 3 factorial. So the 7 entities here will give me 7 factorial, and the red cars will give me 3 factorial. So when I multiply those, I'm going to get for my answer 30,200. That's a 0 and 40. Okay? So mapping it out, thinking about what moves together and what the blocks are. Okay? The 3 red cars must not be parked side by side. So, all together, how does that work? Okay, must not all be parked side by side. So, we can't have them all together. So we're just going to shuffle it. There's 9. I think it's just going to be 9 factorial. So, because it's all... 9 factorial will give us 30,240, doesn't it? Oh, no, it does not. Oh, I know. Oh, because we figured that out. Here they were together, right? Nah. I'm sorry, guys. I had a brain fart. So let's erase this. So what we do, now I know what these notes mean. We take what it is if they're all there, right? All options. And we subtract when they are together, okay? Which was what we did in section B. So all the options are 9 factorial. All together was what we did in section B, which is 30,240. 9 factorial, we're going to get 3,006,280. We subtract the ones where they are together, the options where they are together, and we're going to get 332,640. Sorry, this is like the father sitting in the middle of the movie theater one, okay? I just haven't seen too many like this before, so it's kind of had to wrap my brain around it. And you can also do it that, I mean, it's a little harder to do it that other way that we did with the father because we're dealing with 3 cars. So basically what you have to do is you take, well, what are all the possibilities? And then how many choices do we have where they are all together, which is the 30,240, and you subtract. Okay, those ones are a little trickier. Let's do a couple more examples. So, yeah, one more example here with a couple different situations. Using only the digits 1 to 5 or 0 to 5 without repetitions. How many natural numbers are 6-digit natural numbers? Okay, so let's think about this. So we're going to map it out. So we have 1, 2, 3, 4, 5, 6. Now they have to be 6-digit natural numbers. So the first choice has to be 1 to 5, because if you had a 0 in there, it would be a 5-digit number. So there's only 5 options there. After we take away one of our digits, we're left with 5 more options, then 4, then 3, then 2, then 1. Because here we can have any of 0 to 5, okay? Except for the one that's already been used. So basically it's 5 times 5 factorial, which is equal to 600, okay? Here's a little tip for you if you forget about your natural numbers. Remember, natural numbers start at 1, okay? They don't start at 0, okay? 6-digit natural odd numbers. So let's map that out. So I have 1, 2, 3, 4, 5, 6. Remember, the first one has to be 1 to 5, but we've also put in the restriction that it's odd numbers, right? So looking at odd numbers, that means that there are only 3 choices for our last digit. But we can choose 0 to 5 for our middle digits, okay? So let's map this out. 1 to 5, I have, and I know that I have fewer choices because of that odd number. So let's start with that one actually first. I have 3 choices there. Start with your restrictions. And then that means from between 1 to 5, none of those choices, 1, 3, and 5, are 0. So that means I've lost a choice here. So that would give me a 4. But I still have 4 digits left to fill out the middle part. So I go 4 times 3 times 2 times 1. So my answer, I'm going to have 4 times 3 times 4 factorial, because this basically is 4 factorial, which equals 288. So you have to think about the order you do that. If you started with assuming for that first digit that you had 5 choices, you wouldn't account for the fact that you have to use one of those 3 odd numbers for your last digit. Okay, so you actually have to start with whatever restriction is going to limit you first. Let's do one more example, and then it's practice. 6-digit natural numbers with alternating even and odd. So alternating even and odd digits. So we're going to map that out. And here's the thing. There are, it's going to be an or question, because you could have either starting with even, or you could start with odd. So I don't know what I was going to write there. So let's do the first one. We're starting with even numbers. Okay, even starts. So we're going to go E, O, E, O, E, O. All right. So let's think about this. I can't start with 0. Let's map this out. My even digits are 0, 2, and 4. And my odd are 1, 3, and 5. Okay, so looking at my even, I only have 2 choices for the beginning. Looking at my odd, I have 3 for my second. My even, I still have 2 choices left because now I can use the 0. My odd, I only have 2 left. My even, my next is going to have 1 and 1. So that's what I'm multiplying. So it's equal to 2 times 2 factorial times 3 factorial, which is equal to 24. You could also just multiply those numbers. Odd starts, because we didn't say alternating even and odd, but we have to start with even. It's just alternating. So we could do with starting with odd. So even, odd, even, odd, even. So starting with odd, I actually have 3 choices because none of those 3 digits are 0. Then for even, I have 3, then 2, then 2, then 1, then 1. So I actually have 3 factorial times 3 factorial, which is 36. And it's an or question because it's one or the other. So I'm going to add them, and I'm going to get 60 as my final answer. Because this, it's one or the other, so add. Okay? Tricky. Mapping it out, drawing a little picture, thinking about what happens and how many choices you have at each step really, really helps. You can use your permutation on your calculator if you know that. You can use the formula if you know it. You can just map it out and multiply straight across, because if I look at this last one, if I went 2 times 3 times 2 times 2, I will get 24. If I go 3 times 3 times 2 times 2 times 1, I will get 36. So I didn't have to write it in factorial notation. I just did to show you the option. Use what works for you. Okay? This